Alright gang, I'm going to try to share some solutions from the Azmerit reviews 1 through 3, and I'll try to explain some of the processes as I go through, hit some of the big points. I would also recommend going through the Canvas modules, 1 through 10, and just go through each and every one and make sure you're good on each of those concepts. Because these reviews 1 through 3 won't cover, the whole year's worth of concepts. So highly recommended. Okay, so let's run through a little bit of this. So the first one, it asks which of these points are on the same line. Well, it's really going to be helpful. I guess you could plot the points and kind of try to see if they're on the same line, but you really need an equation of the line to be able to determine if the other points actually satisfy it. So you know how to do that. You're going to take 2 points and you have to calculate the slope. So we calculate the slope by subtracting the y values over the x values. And when you do that, you can see that you get 5/4 when you reduce it. And then you have to use the point slope form, which is this, y minus whatever the y coordinate is. You can see the point I chose was -4, -4, -5, so y minus the y coordinate equals the slope, and then x minus the x coordinate. And then you can distribute a little bit there. So you can see I've got the x plus 4, and then I distributed the 5, so then you get, or 5/4, so then you get 5/4 x plus 5, and then you can subtract the 5 on each side. So you subtract 5, and when you do that, that's where you get the y equals 5/4 x. And then take that and start plugging in those points and see which points actually make the equation true. And the ones that I have listed there actually make the equation true. When I say make the equation true, I mean it satisfies it, right? So if you put a 12 in there, for example, if you put a 12 in for the x, then that would look like this. It would be y equals 5/4 times 12, and you can see that the 4 would cancel with the 12, so that would be a 3 times 5, that would give 15. So that's why that first point works. And so then you do the same for the rest of those that do work. And if it doesn't satisfy it, then it's not on the line. Okay, this one's a pretty challenging word problem, so you're supposed to come up with the savings. There's a difference between the 2-gallon low flow toilet and the 5-gallon, so that's a 3-gallon savings each time they flush. It's 3 cents per gallon, so that's how much they're going to save. They're going to save 3 gallons times 3 cents, and then times however many times they flush. And then it's going to be minus because they're going to have to pay out that $72 initially. So multiply those together, 0.09x minus 72 equals the total amount of savings. So for it to be paid for, there would be 0 savings. They would just be breaking even. So that's why setting it equal to 0 would work. Solve for x and you get 800 flushes. This one talks about different prize monies, and it says that each one gets 25 less than the previous. I went the opposite way and I let x be the lowest prize, and then the next one would be 25 more than that, and then 25 more than that, and 25 more than that, and 25 more than that. So this represents the five place earnings. So the x is actually 5th place, and then x plus 100 would be 1st place. And again, each time you can tell I've added 25. Then you solve this equation by adding up all the x's, and you can see you have 5 x's, so you add them, you get 5x, and then you add the numbers, that's 250, and then subtract 250, and you can tell that x would be 100. So that means 100 is not the first prize, but the 5th prize. And then each one you keep adding 25. And so the best, of course, is the first prize, which is $200. But it asks for all of the places. Okay, Jerome is constructing a table of values to determine if it's a function. Remember, if it's a function, you cannot repeat the x's. Not allowed to repeat the x's. So all you have to do is look at these numbers and see which ones would make it so that you wouldn't be repeating the x's. And that's why I picked the -5, because you can look at this whole table and see that there are no -5s. Sorry, I lost that for a second there. So -5 is not being utilized, -1 as well, and then same with 2. You can't put a 1 there, because if you put a 1 there, you can see that it already has a 1 for the input. The input are the x's. Okay, one theme that is going to come up pretty often is average rate of change. So I want you to think slope. So slope, think subtracting the y's over subtracting the x's. So we're going to take the money, those would be the y values, so 2130 minus 1140, and then we want to subtract, on the bottom, we want to subtract how much time has passed, and that's the number of months. So July is the 7th month, and January is the 1st month. So we subtract those, that's 6 months. So 990 divided by 6 months, the average rate of change per month is $165. Okay, again, rate of change is always slope. So you have to, in this case, it's talking about going from 3 square feet to 7 square feet. So it looks like it's going from here to here, and then seeing what the y values are. And again, you can look at the y values, that's the 1.5 and the 1.0, and always subtract the y's over the x's. So 1.5 minus 1 divided by 7 minus 3. Keep simplifying, and that gives you 0.125 for your rate of change. If you're looking for the intersection point, that's it. You're just looking to see where they cross. And to me, it looks like it crosses at 1/2, 0. So that's what I put. Okay, systems of equations are really important. So you want to be able to model real-world situations with systems. So the two equations that make sense for this are the shots. So x plus y equals 26. That would be if you let x equal, it says, to be the 2-point shots and y be the number of 3-point shots. X plus y is 26. That would give you the total number of shots. And the next equation would involve the points. So you get 2 points for every 2-point shot, you get 3 points for every 3-point shot, that equals the total points, and then you can use substitution as one method to solve this. So the top equation, I solved it for y equals 26 minus x, similar to what we were doing today in the systems, and then take that amount and plug it into the bottom equation for the y, and then distribute and combine your like terms, and you end up with x equals 10. 10 is the number of 2-point shots, and then you can plug in your 10 right there to see what the y value is, and it's 16 3-point shots. And kind of check it to make sure that that actually gets you the right number of points, and it does. This one's pretty challenging. Distance equals rate times time. So just I'm gonna let you just soak this one up. Just take a look at it. Hoping there's nothing too similar to this one, because it's a little much. But you can pause it and kind of examine this particular slide. I don't think there's going to be Pythagorean Theorem on it. It wasn't really listed on our standards, but one thing you'd want to know is consecutive odd integers, so that would be x, and then the next one would be x plus 2. The Pythagorean Theorem is when you take the small side, you square it, plus the next biggest side, you square it, and that equals the very longest side, which is called the hypotenuse squared. So the one that looks good for the Pythagorean Theorem looks like B. Did that look good? Yeah. No, that doesn't look good. Actually, just kidding about that. The D looks good. So that one there. Okay. This one we did a good amount of, so he's trying to earn money in two different jobs. So $8 an hour working babysitting, so 8 times X plus $11 an hour times Y has to be greater than or equal to 200 because he has to make at least 200, so that's earning a minimum. And then it does say that he works 15 hours at the coffee shop, so that enables you to plug 15 in for the Y, multiply those together, and then subtract the 165 from each side, and then divide by 8. And so it turns out to be, that decimal, which we need to round up and say, if he worked for 5 hours at the babysitting job, then that would get him enough money. Similar here, actually this is the systems, the other one's the inequality. So this is systems, so Flourish, they pay $120 an hour, so that's a good equation to model it. Green Thumb charges, $1,600 for the equipment fee, that's like the flat fee, that's the y-intercept, plus 70x, 70 per hour. So if you set them equal to each other and solve for x, then you'll get 32 hours. That's when they would cost the same. If you were doing a job that was 35 hours to complete, which one would you choose? Well, you can just plug in 35 for each of the equations and see which one is, less expensive. The Green Thumb is less expensive. It's $150 less. Whenever you're looking for a system or a solution to a system of inequalities, your point has to satisfy both inequalities at the exact same time. So that's what we would normally be looking for. This one says which one's not in the solution set, so it would not work for one of them. So the one that I found doesn't work is the 4, 3, because when I put the 4, 3 in to the one on the left, it turns out to be 3 is greater than 3, which is not true, so that doesn't work. Okay, linear function, which one's a good fit? So this is the one where we talked about the correlation coefficient. It's supposed to be a number, if it's a really strong correlation, then it would be a number that is very close to 1 or -1. That shows that it's a nice linear fit. So the two that I have marked there are good. -0.93 is pretty close to -1, and of course r equals 1 is great. R equals 0 is terrible. And then this one I went ahead and said would be a good linear model because you could tell it looks like they're moving in a linear fashion. The next one doesn't look good. They're all scattered everywhere. Okay, this one we can just kind of plot the points that they talk about. So it says 3 mints gives you 10 calories. So I just plotted that, 3 mints, 10 calories. And then did that again. I went up. It looks like you go up 10 calories for every 3 minutes. So I just went up 10 calories every 3 minutes, up 10 calories every 3 minutes. Make a nice little line, and that's your slope. And then if you want to write an equation for that, you just put your slope in there. You know how it's y equals mx plus b. Well, the y-intercept is 0 because if you have 0 mints, you have also 0 calories. So that's a good equation for this situation. The next one ties into this. It says, what if you have 180 calories? Then that means you should put the 180 in for the calories on the left-hand side, and then solve for x. And you can do that by multiplying by 3/10. So if you multiply by 3/10, you can see the 3's cancel out, the 10's cancel out. You'll just have x. And then on the left-hand side, this will be 18, goes in 18 times, and then times 3. So 54 mints is what would give you that number of calories. Okay, our final review is quadratics. So let's see. If this is our function, then the maximum would be the time one of the coordinates of the maximum would be the time it takes, that time that it gets to the maximum point. What is the maximum point? So we would actually need to calculate this. So it would be, I need to work it. So it's going to be negative b over 2a is going to be when it actually occurs. So this one has an a value of, it looks like negative 16. The b value is actually 0 because it doesn't have an x. And the c is 625. So negative b over 2a, so that is 0, negative 0 over 2a. So x equals 0, it looks like, is the halfway point. So x equals 0. And then we would plug in 0. So if you plug in 0, you get 625. So it looks like the highest point is actually, it looks probably more like this, the parabola. And so this one, the highest point is right at the beginning. So it's actually dropped. Oh, yes, of course that makes sense. So it's actually just dropped, it's not thrown up. So that's why it doesn't have that extra little initial velocity piece in there. So the maximum value is 625. That's the highest that the stick ever reaches. That's the C in this case. This one, we're trying to figure out where they would actually cross. So we're looking at the y-coordinates and seeing when the y-coordinates would be similar. And it looks like you can tell they get pretty similar right around here in between 3 and 4. It's 22 and 23. And then once you get to 4, the function f of x has already bypassed the other one, so we've gone too far. So then you would just keep going with, smaller numbers. So we could try a number between 3 and 4. So for instance, 3.4, and if you plug in 3.4 for each of those, they turn out to be very similar. The y-coordinates turn out to be very similar. So I would say 3.4 would be about the best that we could get for a solution going this route. This one we're looking at what would be the reasonable, they say reasonable constraint. So when you're looking at the graph, you can see they're trying to keep the money above 125, so that's from there to there. So we're focusing now on the x-coordinates, because that's what we would need to worry about, the x-coordinates. So that's from 2.62 to 26.55, so then we'd be able to write that as an inequality. So this is the inequality that represents that. It says x is greater than or equal to 2.62 and at the same time is less than or equal to 26.55. Okay, this one, let's see, we're looking for, this represents the volume, this particular function here, this one. And it says which one would give you when how long it takes for the trough to drain. So if it drained, then it would have 0 volume. So I would say I'd be looking for the 0 of the function. And then if it was in factored form, it'd work out really well. So when I'm looking at these ones on the bottom, I'm trying to look for the one that would be the factored form. But also, if I multiplied them together, it would actually be the same as this. So this particular one is factored, which is what I'm looking for. And then it's also, when I multiplied it together with the distributive property, it's the exact same function. So that's the one I'm looking for that would reveal how long it would take for the trough to drain. So you could set each of those factors equal to 0, and you could figure out those times, or time. Similar question, which one reveals the zeros of the function? So same, you want this factors, so you want to try to look for which one of these is in factored form, where you can multiply them together and actually get the same polynomial, you know, the same little, it's a trinomial, it's a quadratic function as well. So it's all of those things. This part of it itself is a trinomial, but the whole thing is considered a quadratic function. Okay, this concept comes up again, this average rate of change. I want you to think just slope between 2 points, slope. So it says use the graph to estimate the average rate of change of the height in the first 0.25 seconds. So from there to there, that's the first 0.25 seconds. You want to subtract the y values over the x values. So 5 minus 2 is what the heights look like they are at those various times. So 5 minus 2 on the top, and then the time that's passed is 0.25 seconds, so that's on the bottom. And then you divide that, and it looks like the average rate of change is 12 feet per second. That's how fast it's going up every single second. And you can tell it's been a quarter of a second and it's gone up 3 feet. So if it had a full second, it would be going up, 4 times that rate. Okay, now this is an exponential function. See that? See the form? It starts with a 4 and then it has 2 raised to the t. So it says, again, average rate of change during the first 5 minutes. So what you would need is you would need to figure out the time, the number of bacteria initially, which is 4. Remember, that's the initial amount. Also, you can plug in a 0 for the t, and that would also give you 4. So this is the initial amount. After 5 minutes, if you put a 5 in there, then you can see 5 would give you 128. So what's the rate of change? That's subtracting the y's over the x's. So that's 128 minus the 4 over the y value, or the x value is 5 minus 0, and that will give you approximately 24.8, and the units are bacteria per minute. Okay, this one we want to answer, several questions, see which statements are true. We would need to graph that function g of x first. So we graph it, it's just a line, so we put a dot at 2, then we go down 3 and over 1 and connect the dots. Now we can just start answering the questions. F of negative 2 is greater than g of negative 2. Well, that's f of negative 2 is this one here, and it says, is it greater than g of negative 2? And that's not true, because g of negative 2 is way up there. Whenever they say f of negative 2 and g of negative 2, remember those are considered the y coordinates when you plug in a negative 2. So that's not true. The ones that are true is that f of 0 is greater than g of 0. So f of 0, again, is that's this one. That's the parabola. So when you plug in a 0, you get the 8. And then the g of 0 is right here. So that's a true statement, that f of 0 is greater. And then the other true statement is that f of 2, which is right there, is greater than g of 2, which is way down there. So those two are good. Okay, it says this expression can be factored. So we know how to factor. We take out the GCF first. So GCF is 3. That leaves us with x squared minus 11x minus 60. And then we can do a little diamond factoring, 60. Two numbers that multiply to be 60 and add up to be negative 11. Those numbers are negative 15 and 4. So we can go right to our little double bubble. And then you take your factors and you set them equal to 0. And you get 15 and negative 4. So that's why we can circle those two. That'll show up all over the place. And I think that might do it for this video. I hope you study the modules on Canvas. And good luck. Do your best. Have a lot of pride in your work. Thanks.